Okay, so let's begin. Okay, so good evening, everyone, and I welcome all of you to the day three, our third international guest speaker lecture. And today we have with us Mr. Anirban Shah. Uh, we welcome you, sir, and I'm very happy to have you to teach us about the data visualization using ggplot and R Shiny. And we are running a 5 days residential summer school, and the title is R for Researchers. And most of the participants, either they are doing PhD or master students, and they have a keen interest in using R for the research. And we find you an appropriate expert to help us with the data visualization by seeing your profile of being a student of Symbiosis International and an MBA from a eminent institute, and with a huge industry experience and expert of AI modeling and drug plus data visualization, and making use of data visualization industry. So, and we welcome you on behalf of SARA team and behalf of students. So Mr. Anirban Shah, sir, now is over to you. Please start your talk.
Thank you, Dr. Ajay. Hello, everyone. It's always, like a pleasant experience to see new people who are interested in our programming and even data science programming. I think it has come a long way over the years, going back to 2010s and even before that, and where we are now. I think our itself has come a long way, and there's a lot of industry acceptance of this tool. And just like you today, I think I was also there at a point in time where I was learning R for the first time, and then seeing the sort of the use of it, it excited me, and so I pretty much spent a lot of my time last 7 years in building R Shiny dashboards and visualizations and automations, along with machine learning applications in the back with Python. Yeah, so let me share my screen and begin the officially begin the training session. So my presentation today is titled, or the training session is titled, "Building Powerful R Shiny Apps with Minimal Coding Background." I think today, with when we started off doing and trying to build things in R, we had to really look for solutions in the corners of internet, in Stack Overflow, find some community, somebody has answered something, and figure out ways of solving the problems and the debugging the errors in R. And so it took quite a bit of time to learn the basics of R and the syntax of R, which is, I would say, different from Python. But today it's a very different layout we have, right? You have ChatGPT, you have DeepSeek, you have all these other AI models that can code, help you coding. And even if you don't know, at all any coding, you can still today build something, and not just in R, I would say even in JavaScript or in just a website. If you want to build today, you can build it with some good prompts in this LLM model, giving this LLM models, right? So with that in mind, I think it's important today to learn how to utilize these tools and quickly build these apps that would have taken weeks or months to build when LLM models and ChatGPT did not exist. And I think the revolution happened. I mean, this technical revolution keeps happening, right? So when we started we were building our shiny dashboards and telling stakeholders and marketing to stakeholders that, you're doing a process in Excel that takes so much time, but I can build a tool for you, a dashboard for you, with which you can do it in 1/10 or 1/20th of the time. And now again, a technological revolution has brought us to a place where even without coding background at all, you can build it even faster and give impact and value to your stakeholders that That could be your company, that could be the university you're working for, that could be the university you're studying in, the college you're studying in, it could be your college project, it could be your internship. But what is most important is to deliver value via these tools that we have at our disposal, right? In data science terms, that those tools are and shiny right now in open source, right? Um, so with that, so I thought I'll give a bit of introduction of R and how the syntax of R. And in my mind, I've divided this training into three parts. The first part, we are going to introduce ourselves. We are going to talk a little bit about R, Python as well, and basics of R. The second half, we are going to go a little bit into our Shiny applications. I think Dr. Ajay was saying that you guys already have had a training session of installing R and getting the technical setup ready to run your codes in console and also build visualizations. So we are going to build on top of that and try to build our Shiny applications in the second half of this session. And yeah, we'll see some of the details of building our Shiny and what it really takes to build really good looking as well as well performing our Shiny applications, right? So that'll be the second part of the session. And the third part and the last part would be me trying to build our Shiny dashboard with ChatGPT through prompts and without like a lot of manual coding, right? And I think that's what you should do today. Instead of trying to learn the full syntax of R and then try to build on top of that, let it build for you and you improvise it, you make it better, you understand what it's trying to write, right? Um, so yeah, so we'll go into that in the last part of the session, and that I will do it together. So I will also do it exploratory. So I'm going to give prompts to ChatGPT, get some outputs and answer and try to run those outputs to see if it can build an application out of it, right? Um, so that's a like a sort of brief about the whole presentation. I think I covered a few slides, but before we start, these are some of the links. So maybe I'm going to uh, paste the link to this one to you guys. So you can open this sheet, open this PPT and then go to so Posit Cloud is another option to run your R Shiny, just R code without having a lot of setup. But in my experience, it doesn't work very well. It just goes to sleep every few minutes or something. So it's not very useful, I'd say. But yeah, for running some basic R script or codes, you can use this. So Posit Cloud, they have recently come up with this setup now. We of course have the R Studio itself, so which we'll also use. Um, and so to install those, you will need to install R, you will need to install R Studio. So hopefully those are done. And there's a repo which I have there, which will have most of the codes that we'll use for this course, right? And this is for public repo, so you can go ahead and look at it. Any questions before we begin? Okay, so first off, let's have a round of introduction. I would like each one of you to do a basic introduction of yourself, which will be your name, your educational and professional background. What is your expectation from this session? And it's okay if you don't have any expectation and come with open mind. That's fine too. But if you have anything in mind, maybe I can cover that through the course of this session and share one fun thing, one hobby, or any passion that you have outside of work for you. So I'll pause, and if nobody starts, I'll call out names, but I'll pause now for somebody to start.
Okay. Let me make one thing just actually. Uh, this actually we all are sitting in the same hall, so
Oh,
we will not be able to use the mic. But I request all the participants to use the chat, and in that they can drop their
yeah,
name, education, and as per the Anirban's requirement. Yeah, please share.
yeah. It'll be good, to know each other. And
Yes, yes,
hi,
yes.
Dr. Madhu. Nice to meet you.
And Anirban, one request from my side. if you will make the slideshow, then I think we have a better view of the
Better
slides.
view, yeah. Okay.
It will take the complete space.
Yep.
Yeah, perfect.
But
Thank
yeah,
you.
but I am going to jump to link
Yeah.
sometime.
Okay.
Yeah.
No worries. No
Yeah.
worries.
Hey, hi Hardik from TIS. Okay, I have some friends in TIS from TIS as well. Okay, policy and research organization. Okay, that's nice. Hey, hi Jatin. Sociology, anthropology from DU. That's good. That's crazy. Yeah, nice to meet you. Okay, while others type in, maybe in the interest of time, we'll get started. Um, Okay. So about me, I thought that everybody will say, and then I'll come up. Hey, hi, Komal. Currently PhD from Central Political Studies in JNU. Oh, nice. That's nice. Hi, nice to meet you. UG in Agriculture and PG in Development Studies in Sustainable Food System. That's nice. Um, JNU currently learning R. So excited to learn from you. Love traveling and meeting people. Hi, Madhu. Nice to know. Nice to meet you too. Okay, that's nice. So about me, I am from originally from Kolkata. I studied and worked across cities in India and traveling, going where development and opportunities take me. So one of the first degrees I got is finance and graphic design, and I have a diploma in it, but that was in school. I put it here because I think that's relevant to the shiny UI bit, and knowing how your UI should look and feel, so that definitely helps. And then I did electronics engineering, bachelor's, and from Pune in Pune Symbiosis, and then I went on to do an MBA in marketing, finance, and analysis. So marketing was my major, and finance and analytics was minor. So that was in Great Lakes in Chennai, and that's where I actually learned about R as a language for the first time. Before that, I was doing some coding in MATLAB and so on. But yeah, that's kind of where I got familiar with R for the first time. Experience wise, I have been working quite a few companies. I started off my career with Cognizant. Then I went to, in Cognizant, it was more of a programming manager role. So it wasn't very AI and data science oriented. So then I joined Justi, where it was a IT Madras startup, which were trying to build predictive analytics on or predictive modeling on healthcare data. So can we detect glaucoma from eye scan images? Can we detect sepsis before it can happen and be fatal? And so on. So some of those problems, had fun there. Then I moved on to Epsilon. So Epsilon, many of you could be knowing if you're into the R community, is a company that builds R shiny dashboards for clients, Fortune 500 clients. And so there I got an opportunity to work with many different domains, from finance to healthcare to insurance to automobiles and they were all having different kind of use cases for R shiny, even legal. And finally, last June, I joined Bristol Myers Squibb, which is a pharma company which is a competitor to Sanofi and Pfizer and those kind of big pharma companies. So primarily, I am there as a data visualizations manager, and so we try to. So when it comes to pharma, there's a lot of what do you say, scrutiny and regulatory guidance. So you cannot just build any kind of plot and show it to the authority, which in this case is your health authorities like FDA, and you have different health authorities in India. It's I think IMRI or something. So they each have their own standard way of taking submissions. And so it's very strict. So we have to work in a lot of constraints and develop these visualizations. So that's the latest ones. I'm passionate about statistics as well. Did some predictive modeling in my time in Justi, and engineering and design. Outside of work, I play guitar. I play a lot of Dota, and sometimes, when I was a kid, I used to oil paint, and I've tried to start now. I'm trying to start now, so a little bit of that. So that's about me. I have the links down below, so if you need to get in touch with me, feel free to ping me on LinkedIn or send me a mail. And yeah, that's about me. So today, so before I get started with this, I think as a general philosophy, you can feel free to ask any question. Just maybe Dr. Ajay, you can tell me if anyone of you have question, or you can use the mic, or you can use the chat, but I am not monitoring the chat. So if you let me know if there's a question, I'll stop. So, but I'm not going to pause the questions till the end. So you can ask me anytime in between if you have a question. Yeah, it's best to clear them out right now. We will try to take a break sometime. But we'll see how far we go, and then we'll take that accordingly. But if you want to take a break, let me know as well. So that's the general rules, I guess. You can feel free to ask questions anytime. And the more questions you have, that's better. That's the way you will learn. Even if it's very basic, it seems like a dumb question. All questions are dumb. So just ask. You need to clear them out. Otherwise, the successive um, concepts would not be clear if the initial fundamentals are not sorted out. So feel free to ask that at any time. So scope of today, what you will learn, we will delve into both R and Python a little bit. There's a lot of R versus Python um, fight, I would say. But we'll just look at some of the pros and cons there. We'll do a R programming refresher, basic syntax, and we'll also look at the functional programming in R, which it is, but we'll just go through some concepts of functional programming because there are some powerful concepts that uh, R has sort of implemented in its language that takes that gives us a lot of powerful functionalities in terms of developing software in R. Then we'll go through some R Shiny apps. We'll go through a simple R Shiny app. We'll go through R Shiny app that is in modules, right? And what are modules? We will go through all of them. And building on top of that, we'll see how we can use JavaScript and CSS to make the front end even better in our Shiny applications. It will be basic. It will get you started, but we'll see how advanced it can go in this session, given this time. But it'll be basic and get you started, and then you can build on top of it and add more styles and JavaScript. What we'll focus is on the concepts. And then as in the last part, as I said, we'll start off with a data set. We'll give it to ChatGPT and ask it to create a Shiny dashboard for ourselves, and then we are going to see where we can improve on it if time permits. Okay, I'll take a pause. Any questions? Okay, if not, I'll continue. So a little bit of R and Python. So R for data science. Uh, I'm not going to like go into a lot of details of the history of R, but it R is a successor of earlier programming language called S, which was used for statistics. That's why it was called S because well, it's used for statistics, so S. And then R was built on top of it, and R was still because it inherited a lot of the functionalities from S, it was still R was still very statistics oriented, right? So one thing I will say is that in my presentation, I think I don't have a lot of things in the PowerPoint. So if you take notes, I think it could be helpful. But I'll be talking more and showing you more than the text here. Yeah. So that's the kind of background of R. And so R has some. By the way, R itself is built on top of Fortran. So the backend kind of, so you'll see in a lot of the packages G Fortran and all of that, because the finer calculations, the statistical calculations that are in Fortran. Why this is important is because Fortran is very vector oriented, right? So you have vectors are in R are basically a single dimensional array, right? So 1, 2, 3, 4, 5 is one vector. So 1, 3, 2, 3, 5 is one vector. So R is very vectorized. So any kind of statistical calculation is also vectorized. And generally statistical calculations are vector matrix oriented, right? So you'll have like multiplication of two matrices or addition of two matrices and so on. So in R, it's very easy and fast to do the statistical calculations at large scale. That's why it's kind of shines in statistics. Because for any kind of regression model and all, you will need to do a lot of mathematical calculations at scale, right? A lot of numbers. And so that's really easy and fast to do in R because of its Fortran background. Okay, I saw no questions, so good. So I am able to monitor the chat on a separate screen, so feel free to ask there if you have anything at any time. Yeah. So that's why I think R was very good for statistics and is still good for statistics. And there are functions, base functions. R comes with some base functions that you don't have to install any package for. That's already there, and you can use them to do statistics calculations, even regressions and mean, median, standard deviation, and all those things. Right. So that's why it got a lot of lot of interest from data science scientists. On top of that came visualizations, which is just add on. So for visualizations, you have to now install some package which has some functions that are going to print something and plot something, right? The core paradigm of R, of course, is functional programming. This differs from your Python and C++, and those programming languages where you have object oriented as well. When I say object oriented, again, don't want you to get confused, but it's a different paradigm of programming. That's all, because this is focused in R. I'm not going to go into that because these are, a world of their own. So if you go into object oriented, there's a lot of things out there. So I'm just going to say it's a different approach to programming than functional programming, and I'm going to talk about a little more about functional programming and how it's unique, right? And of course, in R, we have this rich ecosystem and community for data manipulation, dplyr data table. You would have already seen some dplyr examples, visualizations, ggplot, plotly, shiny, and then for modeling, for AI modeling, and less AI, I think more machine learning modeling. You have for like random forest and GBM, gradient boosted models, and so on. You have these carrot tidy models and so on. And right now also they have a lot of LLM packages as well there that they're releasing. Posit is releasing. Um, Deep integration with academia, service, and social sciences. That's, I think, very clear. And if you go into any academical stream which works with the data, they'll be using R for their coding needs, especially where there's a lot of data involved. That's always there. And that's been there for a long time now. I think even today and before, it was first the academia that, started using most of R, and then it went to in the industry, because when I started off, industry was not using it. So Uh, I was in the last in the first two companies, I was the only person who was doing something, trying to do something in R. So that has changed now, I think. But yeah, but I think even now the bulk is in the academia and the surveys and yeah, in research. Yeah. Okay, I will pause and or maybe I'll pause a little later, go over Python as well. So Python for data science, Python as a coding paradigm itself is a different category altogether. So Python has Python is a tool that was built. That's an all-purpose programming language. So you can do anything with it. You can create applications. You can create a backend, like a website's backend. You can create data science stuff. So it's a all round programming language that happens to have a good number of packages that helps you do data analysis as well. Um, and it is not pure functional. It can have functions, but it is more object oriented. And again, what is object oriented? It's a way to sort of even organize many functions. So you can pack many functions together in a class. But I'm not going to go again into too much detail because it's going to be too much, right? But it supports object oriented and is also functional. Um, and and um, and because of its object-oriented nature itself, you can, sort of program anything with it, even operating systems and so on. So it's a general purpose programming language. One very important advantage Python has over R is that it's parallel by design. So if I'm giving it a lot of data, it is kind of parallelized in the background automatically without me having to write custom logic and code uh, to make it parallel, which in R we have to, and it's difficult in R. R is single threaded by nature. It can only do one calculation in one, it cannot do two together unless you code it like that, specially. But in Python, so Python is slightly faster actually. And so Python is best for MLAI models where you have to train models on a lot of data set. So that's why it's widely used in MLAI for even ML ops. So having an architecture of machine learning in production. So it's a very production grade system to have. So that's sort of the I mean the USP, the unique point about Python, right? In terms of data science. And a quick summary. So R is more for statistics, visualization, and I'll even say, this R Shiny the dashboarding system. In Python, it's more for ALAI. It's suited for that, and in general, any kind of engineering jobs. Uh, um, Building dashboards in Python is limited, so you can't really build a lot of custom dashboards. You can build simple ones via these kind of tools, Streamlit, Plotly. Um, but yeah, its main sort of use lies in MLAI and data science. R is more for statistics, visualizations, R Shiny dashboarding, custom dashboarding, and your using displaying things in maps, interactivity. So in R Shiny you can interact with the users. So those kind of things are non-existent in Python. Although right now there's a Shiny for Python that's coming up, so that's kind of there. Um, but it'll take time to mature. Yeah. And community, of course, you have academic and government use, and Python is more industry, production grade, and the tech community at large uses Python. And even Linux versions right now, they have Python inbuilt, and they're doing some amount of the work in Python in the Linux operating systems as well. So it's a really production grade software. Before we jump into more R programming, do you have anybody has any questions that I can answer? Okay. No questions. So we'll start with R programming. So R, as we spoke about earlier, is a fundamentally functional programming, right? So everything that you see in R, you see any R code, you are writing any R code, it's either a function that you're using. So you're using a function to do something, or you're inside that function trying to do something, right? There is no other sort of structural element outside of functions. Even lists are defined by a function. So everything that you define or you do in an R will involve a function call or a function use or a function definition. Now, um, a function is very simply, of course, it's a box. You can imagine it like a box, and you give it some inputs from one side, and that could be multiple inputs, one or multiple inputs, and it will give an output uh, based on some or all of the inputs. Right now, this is the most important paradigm in R. I think that you need to understand why this is important. This is very fundamental. This is simple, but this everything in R can be, any code you see can be explained if you just understand this much and consider, that how do I have this big code base and how do I understand it? Put it in this paradigm saying, okay, I have input, I have output. That's it. Now, the functions that have only input and output, they are called pure functions, right? But there could be functions that have side effects. So let's say that you have a function that writes a file, right? So I'm giving it input of A and B. It's supposed to, A and B are numbers. It's supposed to sum the numbers, A plus B, write that to a file and give an output, right? So this writing to a file is a side effect of that function. It's not an output. It's not included. The output is A plus B, which is 3 plus 2, 5 is the output, but we are also writing something somewhere. So that's a side effect, right? And the side effect, it's very important to like not have side effects because it becomes difficult to track. Because inside a function, your pure functions are inputs and outputs. If you have a side effects, um, how do you know that will have a side effect? You'll have to go into the function, read every line, and then figure out what is the side effect, right? So that becomes difficult to track, maintain, and all of that. But it could have a side effect, which is why it's called a hidden part, because it's not explicit. In a function definition in R, if you see, the input and the output will be clearly defined in the function definition. So you'll have some inputs, which are A, B, C, D, and at the end of the function, you'll see return statements or whatever is at the end of the function, that is going to be the output, right? We are going to see some examples soon, but conceptually, it is critical to understand all of R is functional programming. Even what they call R6 classes and S3 classes, they are still functions. If they say somewhere, oh, there are methods, there's a class and there are methods, both of them is a function with special names and special behaviors, right? In R, you cannot have a non-function and do something, be able to do something. That's not possible, right? So it's a very powerful. We're going to see why it's powerful, but it's absolutely fundamental to always keep this in mind when you deal with any kind of R code, errors, projects or anything like that. Um, so there are some, so a lot, so R has some powerful implementations of using the functional paradigm and building on top of that and be able to do things um, that would take 10 lines, but you can do it in 1 line, right? So that's another kind of difference between R and Python, in that R is more elegant. So Python is more readable, right? Any layperson who can read English can open a Python script, read it, and understand what's going on. That is not necessarily true for R. Although uh, tidyverse packages like dplyr and all have made that better and more readable, but R's core competency is still elegant code elegance, right? How can you do 100 things with 1 line of code instead of repeating it or writing multiple lines of code? So one of that is anonymous function. So one of the powerful function implementations that R has is anonymous functions. Um, so what anonymous functions allows you to do is define functions that have no name, right? So as you know, a function needs to have a name. So let's say print. Print is a function. You do print and then brackets and then type something. It prints something, right? So it's the print function. Um, but you can have functions that have no names in R, and use them on vectors, as they call, or list. So list and vector. Which is so if you have a familiarity of JSON or name key and value pairs, so list or something like that in R. So you can have a list of items, right? You can have a list of data sets. So I can have a list of data sets which has iris data set, which has empty cars data set. It will be a list, right? And these kind of list and arrays or vectors uh, can be input to a function like lapply, and this part says that you take one element of the list, which is empty cars, and perform an action on each of the element one by one, right? So if empty cars has, let's say, 10 items, this whole thing is going to run 10 times, picking up one value and passing it uh, as the x here, which will give your unique length. So let's say empty cars itself has 5 columns, right? It will give the unique length of each column in one line of code. Otherwise, you would have to probably write length unique, empty cars dollar column one, empty cars dollar column two, right? You'll have to repeat that 5 times. But this kind of definition allows you to do all of that in one line, right? So lapply, sapply are two functions. I think R has another function also, but the most used is lapply and sapply to do this kind of job where you have a list of items, and you want to do the same. You want to do the same operation on each list of that item, each item of that list, right? So lapply returns a list and sapply returns a vector, which is not important. What is important is to understand that um, via this anonymous, and this function is not named, right? So it's a random, it's just a function definition without a name, where X is one of the items inside empty cars, right? So that's how you can use unnamed function here without defining a name, and you are using a function on the go. I think in Python there's something like lambda which is used. I'm not sure, but I think it has a similar thing in Python as well. And then there's this package called purr. Many of you would have heard it. This is similar to lapply, but it just gives more flexibility. So in lapply and sapply, you can only give one list. There are certain constraints that you have to follow. But purr has many functions where there are no constraints. So you can give two lists. You can give two lists and say that perform from each of the items of first list and the second list, do a 1:1 sort of addition or something, right? So all of the, I'm not going to go into details again, because again, it's a world of its own. But here also, as you can see, this part of it. So what is happening is I have numbers 1, 2, 3, 4, 5. So this is C 1, 2, 3, 4, 5. This is a vector. It's called a vector in R. And then I need the squared numbers of each of this. So I do per map, right? And give numbers, which is a vector. And I have a formula here where dot x is each of this number, right? Sorry. So dot x is each of these numbers 1, 2, 3, 5. So the output of this is going to be 1 to the power 2, 2 to the power 2, 3 to the power 2, 4 to the power 2, 5 to the power 2. It's going to return that as a list in one number. Otherwise, you would have to probably, for each of the items, do square of it one by one, right? But this is also a function call. This is a special formula kind of function call. But you can also have function like this. The same thing as here will work here as well, but per goes a little beyond, and also gives a way to just give a formula and to make it elegant, right? I don't even need function and all of this. I just need to put a tilt, which will indicate it's a formula, and then do the formula itself, write the formula itself, and it's going to give the list of squared numbers. So anonymous function. So this is an important automation, I would say, step, because yeah, from many lines of code, we now just have one line of code. The next one is closures. And closures is probably, I don't like the name because it doesn't kind of explain what it does, but it's a very technical name. And you can read on the left side what it is, but and these are all copied from official documentation. But I'm going to tell you what it is essentially. So with closures, what you can do in R is have a function return another function, another powerful sort of concept, right? I can write functions a plus b, but now I can return a function which will be configured. So here, if you see, it's a power is a function definition. You have a function, you have the exponent, simple function definition in R. And then you have another function here. Now, this is the confusing bit. Where is X coming from? We don't know. X is not defined anywhere, right? So if you ask many people who are kind of okay now doing R programming, they'll say this will throw an error when you run it, right? Because X is not defined anywhere. Where is X coming from? And so it will throw an error, but it won't actually, because R kind of realizes that this X is just another function definition. So it returns this whole thing. It returns this whole function call when power is run, right? So now let's see what it does. So power 2, right? So you give 2 an exponent, okay? And then X, we don't know what it is. We'll leave it as it is. Here also X, we don't know what it is. Exponent I've given 2. So here it will come 2. So now when I run power of 2, now square will be a function which is function of X and then X power of 2. That will be the object inside square, right? Square is actually the function, and where exponent is defined as 2 and your X is what square will take as an input, right? So this is so with this one. So if I had to create a function to cube or square a number, I'll have to create two functions, right? Ideally, one to square and one to cube. But here you see with one function, I can give it power 2, and then it will give me a function that will square. If I give it power 3, it will give me a function that is cube. If I give it power 10, it will give me a function that does power of 10, right? So with this one powerful definition, I have two functions which doesn't need to be defined again and can be used like a square and a cube function. So another powerful concept. I'll pause here again if there are any questions. You can also say if I'm going too fast or too slow, or you want something to be explained again, that's all fine. Okay. If not, I'll move on. Um, okay. So another powerful concept is lists, as I said. So understanding these functions a bit difficult. Statistic moderate. Right. Okay. Yeah, I understand, but I these are not particularly always statistics limited as well. As you, I think, go and try to create real life apps, I think you will realize the need to do some of this. But if you have any specific questions, you can ask me, or I think if you want, we don't need to go to the depths of it right now, because I think for you guys this is introductory. But if you have any specific questions, then I'll try to answer them. But I do understand this as a bit of these are really powerful concepts in R, but hopefully somewhere down the line you will find use for this. Got it. Got it. Makes sense. So we will start off more basics a little bit into the slides. But I want to explain the list of the concept of list as well, because that's also very I think fundamental to R. Um, and um, and like any other language that gives you an option to have a list of items, R also gives an option to have list of items. So here it is defined as a list bracket, right? And then you can have pretty much anywhere as items in the list, anything you want. So it can be numbers, it can be character or any kind of. So this is a very simple yet powerful organization in R, um, because it's difficult to have everything defined uh, in a 1:1, like one by one manner. So right, so if I have a complete list of items, it's like an organizer. Like you can have your clothes in different places, right? One could be on bed, one could be on the table, one could be on in the almirah. That's fine, but you'd want to organize them, put them in a bucket in one space of your cupboard, right? So you can think pretty much of list as the same, doing the same thing. You can have a number of functions spread out everywhere, or you can have a list in one place where you know, okay, all my functions are in this one place, right? So that's all you need to understand, I think, without going into the syntax of it. As you rightly said, this is beginner level, and this is, I promise, this is probably the last difficult one. After this, we'll go into easier stuff. But it's important to know these very powerful concepts in R, I think. Um, so so now we actually dive into probably the refresher course and the basics of R and R Shiny. And we'll start off with very basic now. Yeah. So if you have any questions, please ping in the chat and I'll answer them. But this should be understandable, and you should understand this. Um, so vectors. What are vectors? Vectors are simple one-dimensional, like list, like a I would almost say list, but it's not a list because in our list is something different. But it's an array of similar kind of items. So it can be a vector of numbers, it can be a vector of characters, names, right? And the simple way to define this in R is C bracket and then 10 item one, comma item two, comma item three, blah blah blah. So that's called a vector in R. You can have the length of the vector. The length of the vector here will be 3, obviously, because there are 3 objects. So this is the simplest, what do you say, uh, simplest object that you can have in R. Um, then you have, so once you have this vector of 10, 20, 30, you can do mean, median, SD, and those statistical things with that. And note here how X is not one number, but it's that entire vector of 10, 20, 30, 40, whatever vector is. So you can calculate. So note here that everything is function. So C is a function. Length is a function. C takes what as input? It takes many atomic. So I think it's important that you know these terms. Atomic, in R, it's called atomic values, which means it's one value. So 10 is an atomic value. 20 itself is an atomic value. So so C takes a number of atomic values as input and gives a vector as an output. A length takes a vector as an input, right? Like you see, it's taking this X as an input and outputs the length of that vector, right? Similarly, mean, median, SD, these are all functions. These takes vector as an input and gives the corresponding mean or median or the standard deviation. We don't need to understand what mean is, what doesn't matter. What is important is to understand these are function calls. Similarly, we have data now. A little bit on top of that is we have data frames. So data frames are tables, what you have in Excel, right? But it's in open source code, so you have to define it in some way. In Excel, I will open an Excel, I will type the headers and then start putting some data down. In R, you will call this data frame function, right? And this is what's important. So you don't need to know what data frame does. We don't need to know how data frame is going to do all of this and create a table. We don't need to know. What we need to know, data frame, we need to call the data frame function. We need to give it the column names, name, age, and whatever other column names we have. And then we give it the values. So name is the column one name equal to C, A, and B are the values. So imagine in Excel, you type name, and then in A1 you type name, and then A2, A3 you type A and B, right? And then in B1 you type age, and then B2, B3 you type 23, 24, right? So that's pretty much what we are doing, but we have to do it in code because there's no graphical interface here. So we have to define it like so. And the question then would be, oh, how do I know that how I define a data frame? Um, Go to the data frame documentation, see the examples. What I used to do initially when I didn't know long back is that I used to copy the examples, paste it in my code, and then try to work on top of that. So I need to create a data frame. Okay, let me paste the example in the documentation, and let's yeah, and then let's fill in the things from my code that I want as names and values, and create any other columns that I want to, right? So that's what data frame gives you a tabular data set that you can then view, merge, and do all of the stuff that you can do with a data set, right? Um, then so I'll stop there for data frames. That's an entire topic, I know. And if you have specific questions that you are struggling with the data frame or something, I'll take it up. But for now, let's move on to the next bit, piping, right? So what is piping? So it's important because I think even beginners should know piping, because you will see any kind of tidyverse documentation has pipes. So it's a very simple concept actually, and it has got nothing to do with statistics, but just to understand the concept of piping, right? What pipe does simply is to let you uh, pass the first um, your first parameter we call in R. What are parameters? Parameters are this input to data frame. So mean x is the parameter and mean is the function, right? Median is the function, x is the parameter that you're putting. It's also called an attribute sometimes, but these are basically what input are you putting, right? So what piping allows you to do is the first argument or the first input that you have to give. Instead of giving it in filter bracket df, you give it before. So you give df pipe and then filter, and what will happen is df is going to be passed as the first argument to filter. That's it. That's it. It does nothing else. The only thing it does, whatever you have before the pipe goes to the first uh, parameters equals to arguments. It's also called arguments. Yes, yes. It's also called arguments, also called attributes. Yeah, correct. And what piping does is therefore give the df as the first input to filter. That's it. So if you have multiple pipes, all you have to think of is that everything above that pipe, whichever one pipe I'm selecting, everything above that pipe, whatever is the output, that output is fed to the function after the pipe as the first input. Okay, that's pretty much it. That's all it does. It might look fancy and a lot of things, but that's all it does. And we are going to see some examples of piping soon. In any examples in your documentations in our books, you will see a lot of pipes being used. So yeah, so you have practiced it, yes. So that's what pretty much it does. And then we have functions. Functions we already spoke about, so I'm not going to go into that again. So I'll pause here. If there are any questions or you have difficulty in understanding any of this, we can go over it again. And I'll pause for questions here if you have anything. Okay, continuing then. So we can now take up a very simple R Shiny application. we are going to look at, I think you haven't seen an R Shiny application, like you haven't been in the course of this summer school, you have not been introduced to R Shiny app, I hope, because I don't want to repeat basics things. But as per Dr. Ajay, I think you went to ggplot and DPL wire, but not R Shiny app. So I'll give a brief of what an R Shiny app looks like and what it is, and a little bit of intro, right? And you can tell me on the chat, oh, we already know this. Let's go to the advanced stuff. Yeah. Um, so, so Shiny is a package in R, and you have a. I'm going to little bit go into the Google and show you. So there's a list of tidyverse packages, right? Um, which are built by Posit, which what's happening here? Strange. Their website is down, is it? Um, no worries. Uh, let's see if GitHub is up. So Posit obviously, what they do is they have RStudio ID. They also gave Workbench and this Posit Cloud and all of that, and that's how they generate revenue. But they build a lot of open source tools. So some of the tools are packaged into a universe called Tidyverse, which is very simply a bucket of apps, bucket of R packages that they have built. Right. So, and they pretty much cover all the basics of data science requirements. So DPLY does the data wrangling bit. You can add columns, you can change columns, you can pretty much do anything with a data set that you want to do. The syntax is a learning curve, and I'm not going to go into it into detail. But it works in layers, right? So first I have a data set, then I add a column, then I change that column, then I filter, then I select, filter the data, maybe name starting with A, select column name and age, and so on, right? So layer by layer by layer. ggplot is also similar. It does visualizations. Um, it again has the concept of layers. We also saw some per functions. So they have all of this packaged into tidyverse. Readr is a package that's fast data reading. Right. Rvest is a package for scraping. So if you have used Beautiful Soup in Python or something, so you can scrape websites. You can programmatically scrape websites and pick up data from them. So it has a host of this package, and one of them is Shiny, right? So what Shiny essentially does is it has a lot of JavaScript code, right? And in JavaScript, you have events. So if I click on something, something will happen, right? That's the concept that they have brought into the R coding paradigm, right? Created a shiny package that's going to very easily allow users to create these applications or websites that are interactive. So user selects a different input, the output will be different, and it will be reactive like that. So the concept of reactivity is central to Shiny, right? And it also leads to a lot of confusion, right? This interactivity. But what is very fundamental to understand here in Shiny is that no matter how convoluted the reactivity seems, because once you build your app, you might have one input that decides other input. So let's say that I have selected, I have a list of selection of country, state, and city, right? Based on my country selection, the list of states should change. If I select India, it should show Indian states. If I select US, it should show US states. And even within that state, if I select Maharashtra, it should show me this kind of cities, Pune and Mumbai and Nagpur and all of that. If I right, so all of this reactivity gets really complex in the end. But what is really super important to remember is that no matter how complex it seems, R cannot have parallel reactivity, right? It can only be one by one, right? So once your country has changed, then only state can change. Once state has changed, then only it cannot be that, oh, country has changed and state has simultaneously changed and everything has, sort of parallelly changed as a cascading effect. That cannot happen unless it is coded like that. So it can only do one thing at one time. So it will go step by step. And in the backend, what happens when you sort of start this running, when you run this entire script to run the app, a sort of reactive graph is created, which says that which changes lead to what output changes, right? And that's what is followed. But not important to, not super important to understand all of the backend process, but you need to just understand conceptually that reactivity does trigger, like one input can trigger other outputs, but at the same time, it cannot happen in parallel. It can only happen one at a time, which means that you can track it. And there are some tools to track the reactivity also. Again, I'll not go into that. Those are really advanced when you have built really large R Shiny applications with 5, 10,000 lines of code, then it comes into the picture. But for very basic sense, what we need to understand is that it will have a reactive graph. It's going to follow that reactive graph, and it will it will update the outputs step by step. Um, Now that's reactivity. But of course you have, because it is a front end application, a Shiny application will always have two parts, fundamental parts, and this is very straightforward. If you go to any Shiny like a website, it will tell you that it will have two parts. So I'm not going to go into the basics too much, but it will have two parts: UI and server. The UI part will output. So all of this UI code, all it does is output a HTML chunk, okay, an HTML definition. If you go into any website, uh, and we'll not go into the depths of it, but if you do right click and inspect of any website, you'll be able to these HTML tags calling this is a header, this is an input, this is a file input, this is an output, and so on. Very simple. It. Again, you see all of these calls are all functions. Fluid page is a function. Sidebar layout is a function. Sidebar panel is a function. Fluid page takes as input the title, the layout, and all of the. So I'm not going to go into details of the syntax because this will confuse you. And this understand it. The way to understand it would be to check Fluid Page's documentation, right? Which I think you should do as a part of maybe homework or later exploration, and check out the documentation of these functions. Each of these functions has a documentation. It is clearly stated what are the arguments that should go into it, and there are examples that you can run to get started, right? So all of this UI code does is output that HTML code that says I have a title panel called this. I have a sidebar panel on the left side, which has a heading of choose variable to plot and a select input. The select input has empty cars, column names of empty cars. We're going to run this. Hopefully, I have to stop share and share the studio, but we're going to run this and see as well. And now you just have the UI part here. This is static. I have declared these are my inputs, these are my outputs, but I have no way of showing the output yet, right? So, um, so to show the output, because as you see, plot output is plot, but what does it show? Like where am I plotting it, right? So that has to go into the server bit, right? So you have the let me just switch on the chat. Armin, could you please show a demo example of any sample of output? Yeah, I will do that for this one right now. So this server code is but just to go a little bit into the syntax or the concept of it. So because I have the plot output plot defined here, I want to now tell Shiny that what I want to plot. So this plot output and render plot, these are output and render functions in Shiny. Shiny has a couple of them. Some of them allow you to show plots, some of them allow you to show text, right? And some other things, but these always go in pair. Plot output, rendered plot. Text output, rendered text, and so on. So I'm telling it that, okay, this is my plot. So output $plot. What do I plot? I will plot a histogram. So let me show that by running. I need to stop sharing because I probably need to share our studio now. So let me see. So hope you can see our studio. Yeah. So I don't know if you have questions, but once you start RStudio, it doesn't quite look like this probably. So what I generally do is they have added this feature to add a pane here on the left. So I always enable that to have a full view of the code. And so it's the same code here. So you have the UI, you have the server, and the render plot. So I can run it right now. So let me stop what is already running. Um, and you should be able to do if you had cloned that repo and if you're running the project, you should be able to do that too. One thing you'll have to do is rend restore it. Yeah. Why? Because obviously these needs packages to run and you will need to install those packages. So a quick and efficient way of doing that is with renv. Just by doing rend restore, you will be able to install all the packages in one go without having to install it one by one. So you can do that, and then let me run this. And so there you go. So that's a Shiny app, right? It's very simple. On the left side is a sidebar where I have the columns of empty cars data set. I hope you guys have seen empty cars. Oh, but you're not able to see the application. One second, I have to share again. Let's see. Okay, so now you should be able to see. Okay, this is the app that I just ran. Hope you're able to see it. Let's see. Let me open the chat window. Okay. So this is the app that was built with this code. And as you see, this sidebar is this sidebar panel, right? This one, right? And then this is header. So this is the header. Then you have the select input. This is a select input. What are the choices? Empty car, column names are empty cars. And if you have not seen empty cars data set, let me show you the empty cars data set. So this is the empty cars data set. It's one of the other ones than Iris. I thought everybody uses Iris, so I'll use something else. These are different car models on the left side, row names, and these are the various parameters or attributes of that car, like displacement, horsepower, right? There are some other number of gears and so on. I don't know what all of that means actually, but not important for this. What is important is these column names are what are choices in the app here. Yeah. So that's a very simple application without any modules, without any CSS or JavaScript. It's pretty straightforward, right? Now, next we will go to an app with modules, right? And I'll pause here if you have any questions or you want me to continue, because this is a little bit advanced, and you should know this advanced bit. This will be good for your use cases in the later projects or something. But before going into a little bit advanced things, I will pause, and if you have any questions, let me know. And if you want me to explain anything else also in detail, because we are now going to go into complex stuff. So if you understand this simple one, then it'll be easy to understand the next step also. But if you want me to repeat anything and go into a little more detail of how it is happening, I can do that. No? So I'll move to the next one then. So this is an RShiny app with modules. Now, like I said in the initial, any fancy name you think RShiny throws at you, always think functions. So modules are nothing but a special kind of function that allows you to organize RShiny code, right? Because you will see when you build our Shiny applications, you show it to the users and they'll say, oh, can I have this feature? Can I have that feature? And you're continuously going to add code to it. And initially, when I used to build, I had 1 hour file with 1,000 lines code that became unmanageable very soon. Um, and similarly, what happens with our clothes, right? So we buy so many clothes, so many shoes, and imagine if we kept all the clothes and the shoes and the and the maybe the toiletries, everything together in one cupboard, all jumbled up, right? It'll be so difficult to find something or to change something, right? Or to know if something has finished, right? So therefore, what we do, we put toiletries in a toiletry in a bag in a shelf. We put shoes in a different shelf, and we put our clothes also in different categories and different shelves, right? So that's pretty much what this is. We package the code into separate functions uh, that are um, detached from the main code, except the input and the output, right? Um, and that's obviously more manageable, right? So let's say in that, taking the same example of this app, if I had 15 inputs here and 30 outputs here, right? I would want all those inputs to be in one sort of bucket and all those outputs in another bucket. And that will, now if I want to find, oh, I have to change something in this output, I know that I have to go to this bucket and change it. Don't have to scout through the entire code base and try to find where do I have to change to make and change in this output, right? So that's what it is. So we have, and this is the same output, like the app will look the same, but in the back end, we still have this UI and server, right? But if you see on inside main panel, you have same title panel, sidebar layout, sidebar panel, everything is same. But in the main panel, where before you had in the main panel this plot output, right? We are putting that main panel in a different function, which is mod plot UI. This is the convention generally used to name a module. So you have module plot UI and you have module plot server. So module plot is the module and you have UI and server separately, obviously, because R you have UI and server separately always defined. You cannot have UI code in server and vice versa. So that's a kind of a constraint that we have to go with, that we have to have UI and server separately. So this function is will give the UI, and this function will call the server, will give the server output, right? Again, in R, follow the trace, right? So I have, oh, mod plot UI is called. So where is mod plot UI? Let's see. Uh, so I mean, it might seem very simple now, but when you have a lot of modules, then we'll struggle to find modules. But oh, mod plot UI is here. What does it do? Okay, it has tag list, select input, that same input that we selected before, the select input, and the plot output. So the input and the output are no longer in the main UI. It is in this separate function, and it's nicely modularized. It is within its own like sort of bucket, and it's separated from the code. So this will give me the UI and the input and the output UI. And oh, server. Okay, where is server? So server is here. How is server defined? It has a special definition. So R in Shiny, you have to define it like this. We are not going to discuss why and all of that. If you go into Shiny modules page that Posit has on the website, you will find this template there, right? So this part is the template that we have to just work with without any change. This will always be like this, non-customizable. Well, it is customizable, but we'll take the simple one for now. But we can never change input output session. It will always be input output session. It will always have ID. This will always have ID. So this structure is same. No need to understand. What we need to understand is that, oh, the same thing that we were doing in app simple, which is this output plot, render plot, and histogram, I'm just doing the same thing here, but inside the server function or module, which is called, and then just calling that module. Now, just I know it'll be probably too much and advanced, but again, this is important because without this, modules don't work. Uh, we have to use this namespace function in UI definitions in select input and plot output. Why? That's the way. There are no namespace conflict. Let's just accept that you have to use NS within a module, and you have to use NS like this. If you again go to any standard website and try to see how to Shiny modules, they will also have this template. So this remains constant, and you have to just use NS. Just take that for now. If you do that, it'll work fine. So I will run this app again, and it's the same application, right? It has the variable here, right? And it looks a little bit different, and we can make it look the same. It's not important how it looks, because everything in the UI bit can be pushed around here and there. Okay, I'll not go into that, and we don't need to think, oh, this variable selection did not come here, it came here. Yeah, it's okay. These are all AI generated code, right? So this where I just quickly generated them for this purpose. So which is fine, but it still has the same functionality. Yeah, and it's modularized. So this is our Shiny modules, and I'll again take a pause here, and if you have any questions or anything you want me to elaborate, explain again. Is this too complex, or is this fine? A bit complex, yeah. There's a bit complex. Our Shiny modules are like considered production grade. But trust me, if you should use it even in your simple Shiny apps, because what I've seen is simple Shiny apps becomes not so simple very soon. Be it with your R project or in your this thing. But yeah, do practice this. I think if you use it, it'll be very easy for you. But the next one, we are going to still use modules. Yeah, and not use the simple one, because I have also seen that modules are often spoken of as advanced, but I really think it should be very basic and starting off. Um, so we'll continue with the module, and just understand that the modules are just buckets of code, right? With that, we are now going to look at our Shiny app, which is using CSS as well, right? So CSS and JavaScript are add-ons to the R Shiny skill set, I will say. And anything that you want to make it look better. And I'm not going to. This is not a part of the like. You don't have to probably. Oh, how do I stop this thing? I think this one. Yeah. So you don't have to go into the details, but I'll just show you some examples of how we can manipulate UI elements very easily. Yeah. So you see how that color became red. Yeah. I can also make it background pink. Yeah. So that's how easy it is to manipulate on the front end, the colors and everything, because you might, I think our Shiny apps should look good. Yeah. So I always strive to build our Shiny apps that look good, and CSS is going to help you do that. So here I have a very simple CSS definition, right? It's the same code as before. So it will have this tag list, select input, plot output, right? So tag list, select input, plot output, and action button. We have an action button here. The only thing that is important here and difference is that this chunk of code that defines some CSS. So this is a CSS definition. This is a CSS definition. So CSS works with any kind of selectors. When I say selectors, if you in any website, if you just do right click and inspect, and you should do this, go right click, inspect, and then you have this item. This is this item, the highlighted one. Yeah, this is this plot item. Yeah, and if you right click on it and you do copy selector, yeah. If you want to take screenshots now, you can do that. So copy selector, if you take copy selector, then you're going to have this kind of CSS selector, hash plot one plot. This is called a CSS selector. We don't need to understand what it is. It is actually the ID. So if you see here, ID equals to plot one plot, right? So but we don't need to understand that. All we need to understand, right click, copy CSS selector. Once you have that CSS selector, now with that selector, you can define how it looks like, right? So let's say I want to give this a border, all right? And then I do, or something, maybe, let's see if background works. Oh, background doesn't, I think, work. Yeah, background doesn't work. Maybe take another simpler, uh, uh, yeah, maybe this one. Yeah. So I want to change that color to red. So you see how that choose variable to plot is red. Again, here I'm going to do copy selector, go to this thing, the our shiny code, paste that here, yeah, body, and then give color red. Okay, and that's it. Let's run this and see if this works. That should be red color. Um, oh, modular. Uh, what Oh, this is a different tab actually. So that was a different tab. So we need to give it select variable, let's say, and I'll copy selector, yeah, and then give that selector here. Okay, let's see again. See how that is red color. Yeah, I didn't do it here. Yeah, it's coming from the app. Yeah. So this way you can catch hold of elements and give whatever color or feel or look you want. And really if you go into the CSS, like today I would just ask ChatGPT, hey, I want to make this style changes. What are the code for that? And I'll just paste that here without having to understand CSS too much. So that's what I will do today. But so for example, if I give this selector, so I copied that selector from there, correct? And let's say I give, okay, make this element bold. Okay, there you go. It gave me the code. I copy it. No need to know what is the syntax and what all. Just copy it, paste it here, save it, and run it. You see how it is bold? Yeah, compared to this one, which is not bold. Yeah. So it's that easy now because you have ChatGPT, and that's what you should really do. Don't understand the sort of details of the syntax and everything. I would just, even if you so um if I just take a screenshot, yeah, give this to ChatGPT, make the button red, and I need to give it the selector of the button. So I'll do right click, inspect, go here. Oh, that is selected. See, it's selected. Copy it, copy selector, go to ChatGPT with selector. There you go. So let it do that. Okay, it has done some things. Let's try it. So I paste it here, save it. Let's see if it works. See, it's red. Yeah. So you don't have to know the syntax, how it works. All you need to know is the concept. I need the selector. I need to tell ChatGPT what needs to be changed and let it give me the code, and I'll just paste it here and that's it. Yeah. So that's pretty much, and the rest of it is same. The rest of it is not different. You have the same histogram with everything, and we are just manipulating the look and feel of the app here. Yeah. So this is this part. So do you have any questions or anything you want me to explain again? Is this also complex or this looks easier? Okay, okay, I'll move on. Um, so the next bit is JavaScript. Um, so front end has two parts. This CSS and JavaScript. CSS, as you saw, we can change the color, the look and feel, the bold, it's got to do with the aesthetics of it, right? um, but not so much the functionality. For example, I click on this bar, something should happen. Or I hover on this plot and it should change to red or something like that. So those kind of things, those kind of functional things can be done with JavaScript. Um, Again, just like HTML, you can kind of try your luck here in the, by inspecting, right click, inspect, and you can do some styling here. JavaScript also can be run from a browser itself via the console, right? So generally, when you first do it, it will say this kind of thing that you're not allowed to paste things here. But since we are developers, it should be fine for us to paste. So please type allow pasting below and press enter. So I'll do allow paste. This is what will happen with you too. If you start the first time pasting something in console, it will not work. So you have to do that, allow pasting, and then you can, type things here, or even paste things here. So you can try it here. I'm not going to go into details here. We're going to look at a simple application that uses JavaScript to do something. And what we are doing here. So we have the same CSS here. We are making the header blue, font size to some setting of font size. I'll not go into this 2 EM and why is it EM and what is EM, and because that's again a journey of its own. And if you ask ChatGPT or Google it, you will know what it. It's just basically it's a unit of length or size. We have meters, centimeters, but websites and website development and HTML has different kinds of units of length that defines what will be the size of various things. So that's one of them. So we are just defining that font size. Button is still background, some background color, which is blue, I think, and the color is white. So same CSS, no change. But we have some new JavaScript added here. Yeah. So tag script, and this is tag style. That's the difference. So you call tag style for CSS, and you call tag script for JavaScript. Now, again, JavaScript has its own syntax, all of that. And again, I'm not going to go into it because I have ChatGPT today. I'm going to just do it with it, do something with it. Yeah. So right now we are going to run this basic one, but just understand everything else is same histogram, same modules, everything else is same. Only this extra script is added. What does it do? Um, it will send a hello message. Yeah. And when will it send that? um, it will send that when this is called greet. Okay. So I'll not go into the detail. So this will be a bit complex. Okay. Because um, this involves sending data from R to JavaScript and then getting data from JavaScript to R. And again, I'm telling all of this. I know this might seem confusing. So don't worry about that. All you need to worry about is that there is a tiny JavaScript code that that does something. And when does it do something? It does something when this greet keyword is called. Where is it called? So by the way, one of the important this thing your one of the important tools in RStudio is to find stuff, right? So you can of course do Control F, which is the basic find, which is there in every your software like Word and PowerPoint and all. But you also have this Control Shift F, right? So when you do Control Shift F and you search something, it searches an entire directory in any files if that is present. This is useful when you have your functions in another file, and usually will do that. You'll have functions in a separate file unless you want your file to be 10,000 lines long. You will have your functions in separate files. So you want to find that function somewhere where it is. So if you do Control Shift F, right, you can find across all the scripts where all this greet word is mentioned. You see here how it is coming in. So I know, okay, so I know that when greet is called, something will happen. And where is it called? Oh, it's called like here, send custom message. So add custom message handler and you're sending custom message. So when this is triggered, when this custom message is triggered, greet, it will pass on some values to the JavaScript, and it will run this function here. Yeah. So again, details is not important. What is important is you can run function JavaScript here, and I'm going to run a simpler JavaScript here. So we're just going to run this now and plot it. You see how it says that JavaScript has sprung up to action. Every time I click plot, it's going to show me a JavaScript message, right? And you can do pretty much anything with it with JavaScript. And I'm not going to go into more complex stuff. JavaScript might seem complex because it's the functional bit of it, right? Because you can take you can trigger stuff. You can on hover of this change the color, or on hover of this do something else and stuff like that. So all you need to know as a first introduction is that you can pass on JavaScript inside tag script functions like this, and those JavaScripts are going to run. I can even pass on, I don't need to interact with Shiny at all. So it can just be plain. So if I do, by the way, the print of JavaScript is console.log. So console.log is equal to print in R. So it's the same thing. So, but where it will print is in that console. I'll show you. So let's say, right, I do this. This is what I also do, console log hello. I'll also print hello, and then open the console. Yeah, this is the console. You see, it has printed hello. Yeah. Um, yeah. So when it first started, it printed hello. Now, if I want to print it every time every time I press the button, I just add it along with that alert. Yeah. So, and then let's see it now. Let's see console. Now it has not printed hello because it's supposed to print when I click, not otherwise. So if I do this, see it's hello is printed. Again, I click it. Hello, two times hello was printed. So this is just to explain that you have the ability to give JavaScript code, and with JavaScript you can really do anything. So it all depends on how much JavaScript you want to give. Again, today I will use I will use ChatGPT. I will in fact give this entire code to ChatGPT. Let's say I give this entire code, and let's say we want to add some JavaScript. I don't know what we can. Let's say if I what can we do at JavaScript? If I hover on the maybe if I hover here, then it should give me that alert. Yeah. So let's say to ChatGPT, change this so that when I hover on plot button, then the alert should be triggered. Yeah. Okay, so it is only updated the mod plot UI because that's all need updating. That's the best part about it. It's not going to duplicate code and all of that. So you just paste that. Okay, let's see if it works. You see, if I didn't click it by the way, I just hovered on it and it gives. So, today I'll just do this. If I need any specific like functionality, I'll give the code and take the code that what it gives and try to run it and see. Uh, that's crucial. I'm saying all of this syntax and everything just to make you aware of the concept, but in today's world, you do not need it, right? You can also give this simple our Shiny app and tell that, okay, can you modularize this application? It's going to give you the entire structure of how your directory should be looking like, and where you should place your files and what those files should contain. So you really don't need to understand all of this, but um, I mean, we don't still want to be dumb, right? In the world of AI, we still want to understand how some concepts work. So that's why I'm explaining a little bit, but you really don't need them. So I think that's it for this part of the presentation. Shiny modules plus CSS and plus JavaScript. And so I'm going to now do a live demo. What I'll do is I have a application. I have a data set. I'm going to give it that data set to ChatGPT and ask it to create a dashboard instead of me having to create it, because I don't know coding. I mean, I'm new to it. So I'll let it do it, and let's see where that gets us. So, but I'll pause here, even stop. I don't know, Dr. Ajay, should we take a break or should we continue? I think we do not have a lot of time, but let me know and I'll also pause for any questions that you have, if you have questions.
Fantastic, fantastic. And thank you so much. I understand on a Sunday afternoon, little late
No,
afternoon,
no, this
given
was
your
no.
precious time for to us. And so on behalf of SARA team and the students, thank you so much once again for giving this awesome talk.
Thank
So
you.
thank you, everyone.
Yeah.
Thank you, sir.
Thank you. Bye bye.